Hello students. I still saw on your muddy cards that exothermic versus endothermic was a little muddy, so here's a short video to help you recognize the difference. The first thing is that exothermic and endothermic as terms exclusively refer to the flow of heat in a chemical or physical process. This is completely separate from anything to do with work or entropy. There are a handful of ways that heat energy is represented in a system. First is in the making and breaking of bonds. So bonds, like covalent bonds, ionic bonds, these are ways that chemical systems store heat energy. The second is in the manipulation of intermolecular interactions. So making or breaking a hydrogen bond or a dipole-dipole interaction or a London dispersion force interaction is the same as making or breaking any other type of bond. It's also in the fueling or slowing of molecular motion. Remember that taking the temperature of something is just a way of asking how fast the molecules are moving. So this has to do with the flow of heat as well. Consider a system, some part of the universe that we're going to just take a look at more closely. In an endothermic process, heat is going to go into the system. You can remember this because endo means internal or within. So heat must go into the system to fuel the process. As the process occurs, the internal energy of the system increases. In these types of systems, we treat heat like a reactant. It has to go into the system, and it is associated with temperature decreases. That is because the heat in those surroundings has flowed into the system to raise its internal energy. On the flip side, we have exothermic processes. Exo means outside or outward. Heat comes out of the system as a result of the process because the internal energy of the system is decreasing. In these types of processes, we treat heat like a product, and it is associated with temperature increases in the surroundings because the heat is flowing from the system into the surroundings, raising their temperature. We can also consider heat flow by energy diagrams. So recall from the last semester that in a diagram like this, our horizontal axis is reaction process or progress. So how far we're getting going from reactants to products. And our vertical axis here is the absolute energy level of those species that we're talking about, the reactants or the products or some step along the way. Whenever we want to calculate the delta H for a process, we're going to subtract the heat level of the reactants from that of the products. That's just the convention that we use as chemists. So in our first system, we've got low energy reactants becoming high energy products. According to our equation, this gives us a positive delta H. The internal energy of this entire system is increasing. This is therefore an endothermic process, and this occurs because the chemical bonds in the products are stronger than they are in the reactants. That means we have to add energy to these reactants to get those products to form. That's why it's endothermic. But let's look at the flip side of that. What if we start with high energy reactants and we go to low energy products? Well, this gives us a negative delta H. The internal energy of the system has gone down, so this extra energy has to come out. So in an exothermic process, the chemical bonds in the products are weaker than those in the reactants. This excess energy leaves the system as the reaction occurs. So I hope that helped. Remember that in an endothermic process, we are somehow paying energy into the system to increase its internal energy level. We're investing in it. Whereas in an exothermic process, that extra energy is coming out of the system. Thank you for your time. I'll see you guys next class.